Hey guys, so sorry I can't be in class today, but I still want to do the notes together. So you guys will have this printed out, and I just want to go through what you need to fill in. This is about experimental design, which is a huge portion of the AP Bio exam. It's something that you probably have learned in almost every science class. I know you've learned it when you've taken my class. And it's just the independent variable and the dependent variable and setting up a proper experiment and being able to control the variables. And so it's important in AP Bio because the first question of every FRQ is always an experimental design question. So question 1 out of the 6, that's worth 10 points, is going to be, can you set up an experiment? And most of it is being able to interpret a graph or create your own graph. It is identifying variables. Control a variable is when they really like you to identify. It's identifying independent and dependent variables or stating a null hypothesis. So that might be a term that's new to you. So we're going to go through all of these. And again, as I go through this, please fill in the notes that you have as well. So first thing we have is a hypothesis, which we all know, we've heard the definition of an educated guess or prediction about an experiment. So that's just the same thing that I'm going to put right here, because this is just what we typically have in science. Is first step in the scientific method is develop your hypothesis. And so the hypothesis is an educated guess about results of experiment. And typically we do a hypothesis. Hopefully you guys can see that. One second, let me get my remote to zoom in. Okay. So an educated guess about the results of an experiment is what we would define a hypothesis. And we do this by typically doing an if-then statement. So if I add more fertilizer, then my plants will get bigger. Or in this case that we're going to have down here with the temperature affecting a goldfish, if I make the temperature of the water colder, then the respiration rate will go down. So just guessing what you are predicting. So we would call this, in our class, we call this actually an alternative hypothesis. So make a little note here that this is actually called an alternative hypothesis. Which is what your prediction would be, your best guess for the experiment. Now, that means that it's the alternative, that there's some kind of default hypothesis. And that's what we call the null hypothesis. So if you've taken statistics, you might have heard of this. It's a little bit different in AP Bio. But basically, the null hypothesis says that the independent variable will have no effect on dependent variable. Okay, so abbreviate where you need to. So I just abbreviated here. So that the independent variable will have no effect on the dependent variable. So basically what it's saying is what you're changing in your experiment will have no effect on the outcome. It's kind of like a downer hypothesis. Like what I'm doing will make no effect. So if I add fertilizer, nothing will happen. So I always think of it as like kind of like I said, like the downer one. Like you're like not thinking that your experiment's really going to work. Like if I add water, these plants won't grow. And so it's kind of like the negative version, like the depressing version. But what you're attempting to do is disprove the null hypothesis. So if I say in an experiment, just over here, adding fertilizer, you guys don't have to write this part down, will have no effect on plant growth. This is my null. This is my null hypothesis right here. So adding fertilizer will have no effect on plant growth. Now, I don't really think that's what's going to happen, but That is what we call a null hypothesis. So that if adding fertilizer does change the plant growth, we will say that we have disproved our null hypothesis, and that we can then determine with statistics if there's actually a significant impact from the fertilizer. So a lot of times in science, on your FRQs, they are going to ask you to write a null hypothesis, and it's always just like, changing this will have no impact on whatever you're measuring, okay? And that is so that if there is an impact, you know that what you changed actually caused a result. So it's kind of weird, it's kind of different, but again, it's actually easy to write them. It's just super like, giving the bacteria food will not help them grow. And if you see them grow, then you'll know it's because you gave them food, and we can say that we disproved the null hypothesis. If they ask you to write an alternative hypothesis, that's when you use your own educated prediction. So in this case, our null hypothesis would be adding fertilizer will not have an effect on plant growth. Not going to do anything. My alternative hypothesis, if they were asked me to write an alternative hypothesis, would be adding more fertilizer will increase plant growth. Okay, so that's probably the one you're used to writing, but in AP Bio, they usually have you write the null, which is, again, some kind of weird negative thing that you try to disprove. Now, we've already used the terms independent variable and dependent variable, but I want to remind you what those even are. So the independent variable is what I, being the experimenter, change. It is manipulated. And it goes on the x-axis. So if you are graphing, the independent variable will always be on the x-axis, which, remember, hopefully we're all familiar with this, but just in case you don't remember, the bottom one, the horizontal one, is our x-axis. It will go along the bottom of the x-axis. It is what you are controlling or changing. You are manipulating this. So here, as an experimenter, I would have the power to change how much fertilizer each plant got, or whether or not the plant got fertilizer. I can change that because I can physically get a bag of fertilizer and either put it on the plant or not. I cannot make the plants grow with my mind or with my hands. Like I cannot physically do that. That is something I'm going to measure or record based on what I changed. So what I can physically change, or what I can physically set up as the experimenter, is my independent variable. Now, what am I measuring, or what am I actually recording? That is my dependent variable. So it is what is observed, measured, recorded. It is the data being collected. Okay, so this is the data that they're collecting. This is what are they looking for? Are they what are they measuring? Are they measuring plant height? Are they measuring bacterial growth? Are they measuring the density of, I don't know, bacterial colonies? Okay, so back to bacteria. You get it. What are they measuring? What are they looking for? That is what our dependent variable is. So our independent variable, what we're controlling as an experimenter, is going to affect the dependent variable, which is what we're looking for or measuring. This is going to go on the y-axis. So we can call this the responding variable. All right, so sometimes we call that the responding variable. So we have the set variable here on the x-axis and then the response on the y-axis. Okay. So hopefully this is a review. What you change is called the independent variable, and it affects what you measure, which is called the dependent variable. This depends on that. Control group. How do you know that adding fertilizer actually increased your plant growth unless you have a group that did not receive any fertilizer? So our control group is one that we use for comparison. and it does not receive independent variable. So on a previous FRQ, when I went to an AP conference, one of the ladies there had graded an FRQ, and she said that they wanted a definition of control group, which is kind of a strange thing to ask for in an FRQ. But if they didn't say that it was the group that did not receive the independent variable, they didn't get credit. So if they just said it was a group used for comparison, it just wasn't good enough. So according to the scoring guidelines, you specifically had to say it is the group that did not receive, and in this case that I've been talking about fertilizer, it would be the plant that did not receive fertilizer, or the plant that did not receive, you could probably even say the independent variable. But make sure that you memorize the definition of control group as whatever group that does not receive the independent variable. And again, we use it for comparison so that we can say that our independent variable did affect the dependent variable. And if we can say that the independent variable affects the dependent variable, then we can disprove our null hypothesis, which, remember, the null hypothesis is super negative, saying that the independent variable won't affect the dependent variable. So this is a part of the equation that kind of helps us say, hey, it did have an effect, so I can disprove my null hypothesis. And we're going to get into more detail of how we can prove that it was statistically significant, that it had a statistically significant impact on the dependent variable. So in AP Bio, we bring in statistics. And so when you're designing an experiment, not only do you need to know all this terminology and how to make a graph, you need to know how to actually apply statistics to that graph to say, is it just luck that it grew a little bigger? Maybe it was just, a coincidence. Or is there an actual difference between the plant that received fertilizer and the plant that didn't? Is it due to chance, or is there an actual difference between the two that allows us to disprove this null hypothesis and that proves that this seems to affect this? So all of these things are different tools that we use as scientists, or in this class when we are looking at the FRQs and stuff, and we're setting up an experimental design. These are tools that we use to show that the experiment is valid and that the experiment is statistically significant. Okay, and then we have, this is our control group, and then we have constants, which are just things that need to be kept the same for consistency. So this keeps our experiment fair. I keep talking about the plant and the fertilizer. That's always the easiest thing that comes to my mind. But it's like, okay, same type of plant, same amount of water, same pot, same light. You can't have all different. This one's in the corner and it's not getting any light or water, but it gets fertilizer. And you have to have everything the same and only one thing different. And the one thing different is your independent variable. So that it's a fair experiment and that you're not having any other lurking variables that are affecting your results. So that is kind of our definition and terminology. I'm going to erase all this and I'm going to scroll down, and then we're going to actually do an example on the bottom with the little goldfish. So pause if you need to write anything down because I'm going to start erasing and then scroll. Okay, so here we have an example experiment of how does temperature affect the respiration rate of goldfish. So respiration rate is your breathing rate. And so just as my educated hypothesis, I would think, or my alternative hypothesis, I would think that as we heated up the water, the respiration rate would probably increase, right? But remember, we're not making any guesses. We know that our variables here are temperature and respiration rate. So if I'm writing a null hypothesis, I'm going to say my independent variable has no effect on my dependent variable. So let's go ahead and identify what the independent variable is first, and then our dependent variable, and then that'll help us write our null hypothesis. Okay, independent variable. What is the experimenter able to control? Can they control how fast the fish breathes? or can they control the temperature of the water? They control the temperature of the water, right? So the independent variable here is the temperature. Okay, so the independent variable is how hot or cold is the water. The dependent variable in this experiment would be the respiration rate of a goldfish. Now, that would be easy to write, but a lot of times in an FRQ, they want you to actually think, like, how would you actually calculate the respiration rate of a goldfish, right? Because you can't just look at it and be like, ooh, the respiration rate. And you might not have like a respirometer. So like, what would be something that we could actually look at to determine the breathing rate of a goldfish? So when I think about it, I think of a goldfish and they have their little gills, right? So you could measure how fast like their gill movements are. So I'm going to write right up here that what we're actually measuring is the respiration rate, but we need to think of a practical way. So then I'm going to list some ideas of like, what are some practical ways we could actually measure a respiration rate of goldfish? So we could look at gill movement per minute or second, whatever. When you do respiration, it is, even as a fish, we take in oxygen and we exhale carbon dioxide. So you could look at the oxygen consumption in the water. Or the CO2 output. Or you can even measure the bubbles that are produced. Because the CO2 is going to come out as bubbles. So we could even measure the amount of bubbles that are being produced. So these are just some things that you could think of if they actually ask you to be like practical about what you were measuring. You could think, well, how could I measure a respiration rate? Well, respiration is when you take in oxygen and you exhale carbon dioxide. And so I can measure how much oxygen is being consumed. I can measure how much carbon dioxide is being released. I can measure how many bubbles were coming to the surface. I can measure how fast the gills were moving. Or maybe I just had some really fancy equipment that told me respiration rate. Okay. And then we have constants. What would need to be the same about this? Well, we don't want the same temperature of the water. We want the same type of fish, either the same fish or the same type of fish. So you can pick which one you like better. You could either put the same fish in different environments, or you could just use the same like age and species and general type of fish. Same tank, right? Because you don't want to like stress one out in a tiny tank and then give one a like huge tank and be like, oh, he seems way more chill. All right, so you probably think of a lot more constants. You could go on, but we don't have to list them all. The control group. So this one's kind of weird because water always has a temperature, so you can't be like temperatureless water. You know what I mean? Like that doesn't exist. Like there's a FRQ that has changing pH, and a lot of times people ask to suggest a control group, and everyone wants to be like, use a liquid without pH. And you're like, that doesn't exist. So you kind of have to think of something else. In this situation, since the assumption is either we're making the water warmer than the fish is normal, which is like whatever is normal for the fish, they're making it warmer, or they're making it colder. So in this scenario, I think that you could just pick room temperature water. So either room temperature or whatever temperature that the fish is acclimated to. So if this is just an open goldfish tank in your house and the water is the temperature of your house, then you would keep it at that baseline temperature, and then you would increase or decrease it as your independent variable. Record the respiration rate as your dependent variable. And again, we haven't written our null hypothesis. So what is our null hypothesis? that the temperature of the water will have no effect on the respiration rate. So changing temperature of water will not affect respiration rate of goldfish. So changing the temperature of the water will not affect the respiration rate of the goldfish, or increasing the temperature of the water will not affect the respiration rate of the goldfish. Whatever the experiment's kind of leading you to do, whatever it's set up to be in the little description, you'll be able to know if they're increasing the water temperature, or decreasing it, or whatever. But to be safe, you could just say changing the temperature will not affect the respiration rate. So that is experimental design, just kind of kicked up a notch in AP Bio. The new things that you probably learned were a null hypothesis, and then also alternative hypothesis, which is something you've already been doing for a long time. You just didn't know what it was going to be called. And yeah, that's probably the only things that were news to you in this. So as we continue, we're going to learn about graphing, and then how to create the best type of graph for the right scenario, and then plotting error bars on the graph so that we can determine if our results are significant. So yeah, I think tonight I'm going to give you guys some homework on just looking at different types of graphs, and you'll fill in the blank as you watch a video. So anyway, hope you guys have a great day. Bye.